Good day, everybody. We will be talking about elements of geology, parts of volcano, types of eruptions, geologic structure produced by diastrophism, organic processes, heterogenic processes, stress and strain, and kinds of differential stress. Without further ado, I will discuss to you the elements of geology. The volcano. I know most of us knows what a volcano is, but by definition, the volcano is a rupture in the crust of a planetary mass object that allows hot lava, volcanic ash, and gases to escape from a magma chamber below the surface. We've known a lot of famous volcanoes around our country like Taal volcano, Mayon volcano, Mount Pinatubo, and many more. This volcano may be active or inactive. So as quick overview to the part of volcano, as you can see it at your screen, first the ash, second the lava flow, third the lava dome, then the lava itself, the vent and the tepra above it, the caldera and the lahar below, the fissure, the dike and below the magma, and lastly, the magma chamber. The next topic will be discussed by my group mates.
Types of volcanoes. Types of volcanoes are cinder cone, composite or stratovolcano, lava domes, and shield volcanoes. Cinder cones are the most common type of volcanoes. A cinder cone has a cone shape but is much smaller than a composite volcano. They rarely reach 300 meters in height, but they have steep sides. They grow rapidly, usually from a single eruption cycle. Composite volcanoes are made of classic to intermediate rocks. The high viscosity of the lava means that eruptions at these volcanoes are often explosive. These volcanoes have a conduit system inside them that channels magma from deep within the earth to the surface. They can have clusters of vents with lava breaking through walls or issuing from fissures on the sides of the mountain. Next, lava domes are formed by viscous magma being erupted effusively onto the surface and then piling up around the vent. Unlike shield volcanoes with less viscous lava, the magma from the volcanic dome just piles up and around the vent. Lastly, shield volcanoes get their name from their shape. Although shield volcanoes are not steep, they may be very large. Shield volcanoes are common at spreading centers or intraplate hot spots. The low viscosity also means that shield eruptions are non-explosive. Eruptions tend to be mild in comparison to other volcanoes, but lava flows can destroy property and vegetation. Additional term: volcanism. It involves volcanic activity or phenomena. It is a geological term used to describe the complete range of volcanic eruptions, volcanic landforms, and volcanic materials.
Volcanic eruptions. Volcanic eruption is a process where deep magma erupts onto the surface through a volcanic conduit, thus forming different types of volcanic debris. This process is not limited to those on Earth, as it includes all phenomena resulting from and causing magma within the crust or mantle of the body of a planet or moon to rise through the crust and form volcanic rocks on the surface. Eruptions can either be effusive, which involve thin basaltic magmas that flow freely with small amounts of trapped gases, or explosive, which tend to involve thick magmas with large amounts of trapped gases. Eruptions are classified into several different types and can be named after the particular volcanoes where the type of eruption is common, shape of erupted products, or the place where the eruption occurs. Some of the most common types are Strombolian, Hawaiian, Vulcanian, Plinian, Cartesian, Pleiadian, and Icelandic. Strombolian eruptions. Strombolian eruptions are eruptions that are distinct bursts of fluid from the mouth of a magma-filled summit conduit. Explosions normally occur every few minutes at regular or irregular intervals and can reach hundreds of meters in height that are powered by the bursting of large bubbles of gas. This kind of eruption can create a variety of forms or products such as spatter, scoria, lava bombs, ash, and small lava flows. Such products are also often collectively called tephra, named after the volcano that makes up the tiny island of Stromboli because of its multiple erupting summit vents. Stromboli eruptions. Similar to Strombolian eruptions, fluid basaltic lava is thrown into the air from a vent or vents at the summit or flank of a volcano in Hawaiian eruptions. These form shield volcanoes which are quite large and have gentle slopes. What differentiates the two is that the Hawaiian eruption jets can last for several hours or even days in what is often called as fire fountaining. The splatter from the hot lava falling out of the fountain can melt together and form lava flows, or build hills called splatter cones. This type of eruption received its name from the Kilauea volcano on the Big Island of Hawaii, famous for producing magnificent fire fountains that sometimes reach over 1,000 feet. Kilauea. Volcanic eruptions. Volcanic eruptions are a short, violent, and relatively small explosion of viscous magma. This type of eruption results from the fragmentation and explosion of a plug of lava in a volcanic conduit, or from the rupture of a lava dome. The explosions from volcanic eruptions are very powerful and can reach speeds faster than 350 meters per second, even rising several kilometers into the air. They produce tephra, ash clouds, and pyroclastic density currents. Although they only last several minutes, volcanic eruptions may be repetitive and go on for days, months, or even years. Volcanic eruptions are named after the Italian island of Vulcano, where a small volcano with this type of eruption was thought to be directly above the forger of the Roman smith god Vulcan. Volcano. Plinian eruptions. The largest and most violent of all the types of eruptions are Plinian eruptions. They are caused by the fragmentation of gassy magma and are usually associated with very viscous magma, dacite and rhyolite. These eruptions release enormous amounts of energy and create eruption columns that can rise up to 50 kilometers high at speeds of hundreds of meters per second. To top it off, ash from an eruption column can drift or be blown hundreds of thousands of miles away from the volcano. The destructive power of Plinian eruptions can even blow off whole mountain tops, such as the case of Mount St. Helens in 1980. The shape of these columns are akin to those of nuclear explosions, which are mushroom clouds. It is named after the Roman historian Pliny the Younger after he made the comparison while viewing the 1980 eruption of Mount Vesuvius. Subcategories include subplinian, which are below 20 kilometers, and ultraplinian, above 35 kilometers high. Mount St. Helens. Cartesian eruptions. Cartesian eruptions are a kind of hydromagmatic eruption where magma or lava interacts explosively with water. In most cases, they occur when an undersea volcano has finally grown large enough to break the water surface. Because the water expands when it turns to steam, water that comes into contact with hot lava explodes and creates plumes of ash, steam, and scoria. Lavas created by Cartesian eruptions tend to be basalt, since most oceanic volcanoes are basaltic, most likely named after the volcanic island of Surtsey, located on the south coast of Iceland. Pleiadian eruptions. Pleiadian eruptions occur when a large quantity of gas, dust, ash, and lava fragments are blown out of a volcano's central crater. This material falls back and then travels down the side of the volcano at tremendous speeds, usually faster than 150 kilometers per hour. This is why these eruptions are also known as pyroclastic flows and are one of the most dangerous kinds of eruptions. Pleiadian eruptions received its name from Mount Pelée, a volcano that caused tremendous destruction on Martinique, Lesser Antilles, in 1902. This eruption killed more than 30,000 people and was the worst volcanic disaster of the 20th century. Mount Pelée. Icelandic eruptions. An effusion eruption which results in streams of molten basaltic lava that flow from long parallel fissures. Icelandic eruptions often build lava plateaus, which form when large amounts of fluid flow over an extensive area. Rifting of continental crusts are usually responsible, as the crust thins and allows the magma from the mantle to erupt over an extensive area of fissures. Named after the island of Iceland, which owes its existence to a large volcanic hotspot sitting on a mid-ocean ridge, resulting in over 130 volcanoes.
Let's proceed to the geologic structure produced by diastrophism. But before we go there, let's ask ourselves, what is diastrophism? Also called tectonism, it is the large-scale deformation of Earth's crust by natural processes, which leads to the formation of continents and ocean basins, mountain systems, plateaus, rift valleys, and other features by mechanisms such as plate tectonics, volcanic loading, or folding. All processes that move, elevate, or build up portions of the Earth's crust fall under diastrophism. This includes orogenic and epeirogenic processes. Now, what is an orogenic process? From the Greek word oros, meaning mountain, and genesis, meaning creation, it generally means the creation of mountains. It is an event that leads to both structural deformation and compositional differentiation of the Earth's lithosphere and convergent plate margins. It involves mountain building through severe folding and affecting long and narrow belts of the Earth's crust. The crust is severely deformed into folds. Now let's move on to the epeirogenic processes. Epeirogenic comes from Greek word epeiros, meaning land, and genesis, meaning creation. It involves the uplifting or warping of large parts of the Earth's crust. Tectonic deformations of the Earth's crust form continents and ocean basins. Sea levels rise and fall as new plate materials modify the shape of ocean basins. An example would be the creation of rift valleys and fault lines. So to sum it up, orogenic processes happen when plates converge and fold on top of each other, creating masses on Earth's crust, while epeirogenic processes happen when plates diverge from each other and create rifts or holes on the Earth's crust.
What is stress and strain? A rock subjected to enough amount of stress will deform and is said to strain. The strain could be a change in size, shape, or volume of a material. Stress is similar to pressure. It is similar to the amount of force that is exerted on a body. Strain is the deformation caused by stress. So in other words, strain occurs when there is a certain amount of stress involved, but strain does not have to happen even when stress is involved. There are two types of stress. The stress wherein all forces act equally from all directions is called uniform stress, while the stress wherein the forces acting on the rock is not equal in all directions is called differential stress. So the type of differential stresses are compression, tension, and shearing. The motion of compression is similar to squeezing, going inwards, while tension is going outwards, which stretches the rock. Shearing has the side-to-side motion, or slippage, or translational end of motion.